With histograms from chapter 1, there were 4 things that we talked about to describe that histogram. Those 4 things are shape, center, spread, and outliers. And then for scatter plots, we also have 4 things that we talk about. 3 of them are new, one's a repeat. And those 4 things are the form, the direction, the strength of the relationship, and then the outliers. So the other outliers that go with both of these types of graphs. So let's go through and take a look at these. The first one is the form. So you're going to describe whatever pattern you see in the scatter plot, but the form that we're going to be concerned about primarily in this class is things that are linear. So linear is generally roughly a straight line. That's that y equals mx plus b that you hopefully remember from high school. So anything that looks like it's making either an uphill line or a downhill line are going to be our linear ones. Then we'll have things that are curved. So that could be like quadratics that make parabolas. That could be exponential growth that starts out slow, it goes up really quickly. There's any kind of shapes that could be in that one. And then there's also just no relationship at all. It's just scattered. And we saw an example of that with the first scatter plot we looked at, the one with the age and the salary. There just didn't seem to be any pattern there. Okay, so we have 5 pictures here. 2 of these are linear. The first and third one are linear. The second one is curved and it's a quadratic or parabola. The third one looks like it's probably a cubic, so like an x cubed kind of thing. And then the last one is just no pattern at all. It's just scattered. So in this class, we would indicate that the second and fourth one were curved, and that's about all we do with them. But the first and third are linear, and so there's a lot more that we'll look at how to address those. All right, so that's the first characteristic we look at when describing scatter plots. The next one is going to be the direction or the association. So if it's linear, then these kind of sentences and descriptions are going to apply. If it's not linear, then we'll talk about what we see, but this isn't really an element of that. So if it's linear and it's a line and it's positive, that means the slope is uphill. So as x increases, the y variable is also going to increase. If we have a linear line that is going downhill, then the slope is negative. So we would also say that the direction is negative. And that means that as the x variable increases, the y variable is going to decrease. It's going to go down. If you have a flat line, that's kind of a form of no relationship. And that means as the x variable increases, the y variable stays the same. It doesn't change at all, it doesn't increase or decrease. And then there is no correlation at all. So it's just doing something kind of goofy. We do have 3 examples here. We have a positive one, and you can see, even though there's a cloud of points there, it was pretty easy to draw that blue arrow through there on an uphill slant. So that one would be positive. The picture in the middle, again, the dots are a little spread out, but you can easily fit that line going downhill through there. And then we have one that's just neither positive nor negative.